Number 27. X times kx minus 56 equals negative 16. In the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? Okay, an integer constant just means a number. An integer is any number that we think of like, it's not a fraction, it's not a decimal, it's like negative 5, 22, 0. These are all integers. There's no decimal after them, there's no fraction, no square roots, nothing like that going on. It can be positive, it can be negative, it can be 0. That's an integer. Constant means it doesn't change. So just a number, and it's not a decimal or a fraction. Now, it has no real solution. When we're talking about no real solutions, if we're talking about that graphically, we're meaning that if whatever number I put in there for k, the resulting graph will not cross the x-axis. Those are the solutions. So like if it's a line, that's be considered a solution. If it's a parabola, be no solutions, one solution, two solutions. Because it doesn't touch it, touches it once, touches it twice. That's graphically. If we're talking about this mathematically, it means a number I can put in here for x to make this true. So first, I see when I multiply this, I'm going to get an x squared. So this is a parabola. Right off the bat, it's a parabola. And there is a way with parabolas and with the quadratic formula, the formula we use to solve quadratic equations, that can tell us when there's no solution. So that's immediately where my mind is going. First, I want to turn this into a more recognizable quadratic equation. So to do that, I'm going to multiply these things on the left and distribute them, get it all looking more normal for a quadratic equation. First, x times kx is kx squared. Then x times negative 56 is negative 56x. And that equals negative 16. Now I mentioned the quadratic formula, and that is saying that when I have a quadratic that is in the form of ax squared plus bx plus c equals 0, that part's important, it has to equal 0, and a, b, and c are constants, they are numbers, that if I have a quadratic in that form, I can solve for x like this. X will be equal to negative, or the opposite of, the b value, plus or minus the square root of the b value squared, minus 4 times a times c, those values, all over, and I keep writing too big and running out of room, all over 2a. So I'm close to being in that form up here in the green on the right, but not quite. It's not equal to 0. To make it equal to 0, I want to move this over. To move it over, I'm going to do the opposite. Since it's a minus 16 or negative, I'm going to add 16 to both sides. So on the left-hand side, I get kx squared minus 56, I wrote 5x, 56x plus 16, and then minus 16 plus 16 is just 0. All right, now it is in this form, ax squared plus bx plus c. In this quadratic formula, there is one part, one little subset of it, that determines how many solutions there are. And it's this bit right here under the square root. Why would that determine things? Well, what happens if I take the square root of a positive number, like the square root of 4? The square root of 4 is either a positive 2 or a negative 2. Two possibilities. What if it's the square root of 0? Well, that's just 0, right? One possibility. What if it's the square root of a negative number, like negative 1? There's no possibilities. There is no real solution. So that's what determines it. If this b squared minus 4ac, the bit under the square root, is a positive number, you will have two solutions to that quadratic. If it turns out to be 0, you have one solution. If it turns out to be negative, you don't have any solutions. So that little piece, that b squared minus 4ac, it has a fancy name. It's called the discriminant. And I really hope I'm spelling this right. Discriminant. Now, to be clear, this is why I'm going through all this in great detail, is because these two things, the quadratic equation, the quadratic formula, and the discriminant, they are not included in that little chart at the beginning of the section where they give you a lot of the formulas for volume, area, special triangles, things like that. This is not in there, and yet it does come up on the SAT. That's why I'm taking a second to go through it, because especially if you're aiming for those, those high scores and you want these, these are the higher number questions, they get harder as it goes. If you're wanting to get those right, this is one of the pieces of information I recommend knowing. Okay, so we don't have to look at this whole thing to determine how to do this with the equation having no real solutions. All we need is that discriminant, b squared minus 4ac. So, okay. So then you're like, Lisa, why did you do that then? Why did you tell us all this if we didn't need that? Well, you need it for other things, and plus I think it's helpful to know where it came from, so I'm not just telling you, pull random numbers out of thin air and it will tell you this magical answer. There's a reason. There's always a reason in math, right? Yeah. Right, so the discriminant is b squared minus 4ac, and we want this to have no real solution, so it needs to be negative. How would I set this up? I want b squared minus 4ac to be negative. Another way of saying that in equation form is less than 0. So I am going to plug my b's, a's, and c's from up here. There's my a, there's my b, include the negative with it. There's my c, include the positive with it. Now plug them in here, and I'm going to solve this equation. So first, my b. My b is negative 56. I'm going to square that. And then I'm going to subtract 4 times my a is k, positive k, and my c is 16. And this all needs to be less than 0. And my chair is really squeaking today, and if you can hear that, I apologize. I need some WD-40. So I'm going to bring this up here. So negative 56 squared, I wrote it down because, no, I can't do that one in my head, is 3,136 minus 4 times k times 16. I'll do 4 times 16 is 64, 64k, so minus 64k is less than 0. Now I have a pretty straightforward algebra problem that I can solve. First, I am going to get rid of that 3,136. I'm going to subtract it from both sides to get rid of it and end up with negative 64k is less than, make sure that k is connected so it doesn't look like another less than, is less than negative 3,136. And now I want to divide both sides by negative 64 because that's undoing what's been done to k. K is being multiplied by negative 64. So I'm going to divide by negative 64. Right, so when I divide this, I get 49 on the right, and I get k. What is the sign in the middle? Anytime we divide or multiply by a negative when we're solving inequalities, we reverse the sign. So important to do that. Critical to do that. You have to. And if you're wondering why that happens, like why would you reverse it? I'm going to do this as a little aside right here, and then we'll come back to the main thing. I want you to understand things. I know I over-explain sometimes, but I really want you to understand these math concepts, to know what's going on and not just memorize rules. Let's go back to this step right here. 3,136 minus 64k is less than 0. What would have happened if instead of getting rid of the 3,136, what if I had dealt with the negative 64k? What if I added 64k to both sides? Then I would have had 3,136 is less than, I wrote 64.6, sorry about that, 64k. I would divide both sides by 64, going through this quickly, and I would have got to 49 is less than k. Look at that. It's saying 49 is less than k, or k is greater than 49. That big mouth of the crocodile is pointing towards the k, and look at what's happening over here. big mouth of the crocodile. I don't know if you heard that in elementary school. That's how our teachers taught us. The crocodile eats the bigger number. The big mouth of the crocodile is pointed towards the K. That's why we reverse it, because if we just added it, the K would have moved to the other side. It would have been on the other side. That's what's going on. Little digression. If that wasn't helpful, I apologize. But hopefully that'll help you remember, when you divide by that negative in an inequality, you reverse it. So K is greater than 49. Does that mean 49 is my answer? No, it doesn't. Why not? Because it says, what is the least possible value of K? Could K be 49? It could not. It is not. K is greater than or equal to 49. Nope. K has to be greater than 49. And we know it is an integer constant. It's one of those numbers on a number line. So it is 50. One last final thought is, if you didn't know about this whole thing where it changes direction when you divide by a negative, you would have known something was up when you got to, if you would have seen it as K is less than 49. And then when it says, what is the least possible value of K? Well, K is less than 49. Think about it like on a number line. If you hear it 49 and it's less than, what's the least possible number? That's infinity. So you would have realized something was up at that moment. It would have been like, what's going on? But that's some valuable time trying to figure out what's gone wrong and having to work back and figure it out. And, it's always easier if we just have that information in our head immediately for access. So I know that was a bit of a long explanation. I added some extra stuff in there. I hope it was helpful and not just extraneous info that you were skipping past. But the answer is 50. And congratulations, you have finished this section of this practice test. Hey guys, this video was helpful or useful in any way, please feel free to let the algorithm know about it. Like, share, comment, subscribe, even buy me a coffee if you're so inclined. Links for that down below as well. Thank you so much for stopping by. I hope you have a great day. See you later. Bye.